Hello there, hello all. Welcome to Learn with Mr. Tamuli. If you are keen to learn, you have found the right tutor. That's me, Mr. Tamuli. Be assured, you will be able to learn thoroughly with Mr. Tamuli. Let me introduce to you someone who is very intelligent and smart. Here comes Subhodip. Subhodip will present this tutorial on my behalf. I am sure you will find Subhodip's presentation very absorbing.
Hello friends. My name is Subhodip. Actually, I am a virtual assistant of Mr. Tamuli. I shall present this tutorial on behalf of Mr. Tamuli. Currently in our tutorials, we are learning 6th standard mathematics. This series of tutorials is for the first chapter of your textbook. The name of the chapter is Knowing Our Numbers. This tutorial is an upgraded and improved version of the tutorial number 1. In this tutorial we shall learn one of the very basic concepts of the decimal number system, which is the concept of place values. In other words, we shall learn the method of writing numbers in the decimal number system. I shall explain the concept of place values using animations and images. So let's get cracking. You would know from what you have learned in 4th and 5th standard, the place values 1, 10, 100, 1000, etc. For example, in the number 3548, the place value of the digit 8 is 1, the place value of the digit 4 is 10. The place value of the digit 5 is 100, and the place value of the digit 3 is 1000. Let us try and consolidate our understanding of these place values. Suppose your father calls from the office and asks you to count the money that is kept in the drawer of the bedroom table. And you find that there are 3 1000 rupee notes, 5 100 rupee notes, 4 10 rupee notes, and 8 1 rupee coins. So the total amount of money is 3548. You can send a WhatsApp message to your father and write 3548 in the message. Even though 1000 rupee currency notes are no longer in use nowadays, for the sake of simplicity, here we are assuming that 1000 rupee notes still exist. From this example, what we have understood is that in the number 3548, the value or place value of the digit 8 is 1. The place value of the digit 4 is 10. The place value of the digit 5 is 100, and the place value of the digit 3 is 1000. This is why we say that the decimal number system is a positional number system. Different positions or places have different values. If we write the digit 3 in the first position or place, its value is just 3. If we write the same digit 3 in the second place, its value becomes 30. When we write the digit 3 in the third place, it becomes 300. And the value of the same digit 3 in the fourth place becomes 3000, that is equal to the value of the 3 1000 rupee notes that you found in the drawer of the bedroom table. When you are asked to expand a number or write the expanded form of a number, you make use of these place values. So when you expand the number 3548, you write 3 times 1000, plus 5 times 100, plus 4 times 10, plus 8 times 1. In order to consolidate our understanding of place values even further, next we shall take the example of a 2-digit number. And this time we shall try to understand the place values with the help of some tennis balls instead of currency notes and coins. Let's take the 2-digit number 45. As you know, in the number 45 the place value of the digit 5 is 1, and the place value of the digit 4 is 10. This time we shall use 5 tennis balls to represent the value of the digit 5 in 1's place. And to represent the value of the digit 4 in 10's place, we need 4 separate collections or groups of 10 tennis balls. In the previous example we used 10 rupee notes to represent the value of the digit in 10's place. In this example we are using groups of tennis balls. And each group contains 10 tennis balls to indicate the fact that they are in 10's place. Now if we write the expansion of the number 45, we shall write 4 times 10, plus 5 times 1. What we can also learn from these two examples is that the most basic or primary use of numbers is for counting. In the first example we counted 3548 rupees. In the second example we counted tennis balls. Suppose we are given a large box containing tennis balls and we are told that there are less than 100 balls in the box. Let's count the exact number of balls contained in the box using the decimal system of counting. Since we already know that there are less than 100 balls, that means the third place or the hundreds place will be empty. So we shall make groups or collections of 10 balls and keep them in the second place, as we know that the place value of the second place is 10. After we have made 5 such groups of 10 balls, we are left with 3 more balls in the box. We shall place the remaining 3 individual balls in the first place, as we know that the value of the first place is 1. So to indicate the total number of tennis balls in the box, we shall write the digit 5 in the second place and the digit 3 in the first place. That's 5 and 353 as per the decimal number system. This is so simple. To indicate 53 balls you just write two digits, a 5 and a 3. You don't have to draw all the 53 tennis balls. So we have seen that the decimal number system is a very convenient system of counting and writing numbers. In the first place we count in ones or one by one. In other words, the place value of the first place is 1. In the second place we count in groups of tens. That means the place value of the second place is 10. Similarly, the place value of the third place is 100. And we count in groups of hundreds in the third place. To understand this, let's quickly look at an example of a 3-digit number. Let's take the number 534. In this number the first digit from the right is 4. And as we know, its place value is 1. Therefore, like the previous example, let's have 4 tennis balls for this digit 4. For the second digit 3, whose place value is 10, let's have 3 groups of 10 tennis balls. Place value of the third digit 5, as we know, is 100. Yes, for this digit 5, we need 500 tennis balls. So we shall bring in 5 separate groups of balls, each group containing 100 balls. This is the correct representation of the number 534, with 534 tennis balls. We all know that the place value of the third place is 100. In terms of counting, we can say that in the third place we count in groups of hundreds. This is what I wanted to show you through this example. Let us now move to another important aspect of the concept of place values. Watch this very carefully. The place value of the first place is 1. 10 times 1 is equal to 10, which is the place value of the second place. Again, 10 times 10 is equal to 100, which is the place value of the third place. Similarly, 10 times 100, or 10 multiplied by 100 is equal to 1000, which is the place value of the fourth place. So you have seen that any place value when multiplied by 10, gives us the next higher place value. This is true for all the place values, and is one of the most fundamental aspects of the decimal number system. We will be able to understand this concept really well, using our tennis ball examples. For this we shall solve a few, very simple problems of addition. First let us add 34 and 8. To solve this simple arithmetic problem, we begin by writing the first number 34. We shall write the other number 8 below the first number 34. As per the procedure of adding numbers in the decimal system, we will make sure to write the digit 8 exactly below the digit 4 of the first number. Now we shall add the digits in the first position. So 4 plus 8 is equal to 12. Therefore we write 2 in the first position. And 1 is carried over to the second position. Now let's add the digits in the second position. 1 plus 3 is equal to 4. So we write 4 in the second position. And we get the answer as 4 and 2 42. Now let us visualize this addition arithmetic through our tennis balls. This will give us a great insight on the concept of place values. First, let us get the tennis ball representation of the number 34. Next we shall bring in our second number 8. Now the first step is, 4 plus 8 is equal to 12. That means, we shall combine the individual tennis balls that are there in the first place of both the numbers 34 and 8. Now we have 12 individual balls in the first place of the resultant number. But as per the decimal system of counting, you cannot keep 12 balls in the first place. Let me explain. You know that in the decimal number system there are 10 digits. They are 1 through 9 and 0. 0 is the smallest digit and 9 is the largest among the decimal digits. Now let me take a random number, say 25. In the number 25 there are two digits, 2 and 5. 5 is in the first place, or position. And 2 is in the second position. Like 25, all the numbers that we write in the decimal number system are combinations of the primary digits, 1 through 9, and 0. These 10 digits can be compared to the alphabet of the English language. All the words that we write in English are combinations of letters of the alphabet. Similarly, with the 10 digits of the decimal number system you can write all the numbers, big or small. Now coming back to the problem of having 12 balls in the first position, you cannot write 12 in the first position. 12 is not a digit. It's a number. In any position or place, you are allowed to write a single digit. The smallest digit you can write is 0. And the largest digit that you can write is 9. So in our resultant number, we can keep a maximum of 9 balls in the first place, but at the moment we have 12. To solve the problem, what we shall do is, we shall move a group of 10 balls to the second place, because we know that in the second place we count in groups of 10s. This operation is actually the same as carrying over one of 12 to the second place. Now we are left with 2 individual balls in the first position. So we can now write the digit 2 in the first place. Let us now bring the 3 groups of balls from the number 34 to the resultant number. So, in the second place of the resultant number we have 3 plus 1, that is 4 groups of balls, and each group contains 10 balls. Therefore we can now write the digit 4 in the second position. And our resultant number is 42. The most important thing that we can learn from this example is, in the first place, or in any place for that matter, we can write any of the decimal digits from 0 through 9. 9 is the largest digit. Therefore we can say that the largest single digit number is 9. In terms of counting, we can keep a maximum of 9 balls in the first position. The moment you add one more ball, it becomes a group of 10 balls. And this group moves to the second position, to which it belongs. In terms of counting money, you can keep 9 1 rupee coins in the first place. If you add one more, it becomes a 10 rupee note, and moves to its correct position, that is the second position. In mathematical terms, 9 is the largest single digit number. With 9, if you add 1, you get the 2-digit number 10. Actually, the meaning of decimal is based on the number 10. The decimal number system is based on the number 10. Or we can say that the decimal number system is base 10 system. There are other number systems that can be derived from the decimal number system. For example, the binary number system is base 2 system. The octal number system is base 8 system. The hexadecimal number system is base 16 system. These subsystems of the binary number system are used in digital computer technology. Let's look at one more example to try and understand why we call the decimal number system a base 10 system. With 285, let's add 46. 5 plus 6 is 11. So we have 1 in the first position. And we carry over the other one to the second position. Adding the digits in the second position we get 1 plus 8 is 9. And 9 plus 4 is 13. So we write 3 in the second position, and carry over 1 to the third position. In the third position we get 2 plus 1 is 3. So our answer is 331. Now let's watch the tennis ball analogy of this arithmetic. First we shall get the tennis ball representation of the number 285. Now let's get the number 46. We can now add 5 and 6. That means we shall combine the 5 balls located at first position of the number 285, with the 6 balls located at the first position of the number 46. So we now have 11 balls in the first position of the resultant number. Out of these 11, a group of 10 balls shall move to the second position. That means we carry over 1 to the second place. As we are left with 1 ball in the first position, we can write the digit 1 in the first place. Next operation is 1 plus 8 plus 4. That means we shall combine all the groups of 10 balls that are there in the second position. So we have 13 groups of 10 balls in the second place of the resultant number. But we cannot write 13 in the second place. Please observe that 10 groups of 10 balls make a group of 100 balls. Mathematically, 10 times 10 is 100. 100 also happens to be the place value of the third position, or place. So the group of 100 balls shall move to the place where it belongs, that is the third place. Please note that this movement represents carrying over the 1 of 13 to the third place. As we are left with 3 groups of 10 balls in the second place, there we shall write the digit 3. Also in the third place we now have 3 groups of 100 balls. Therefore we write 3 in the third place. So the resultant number is 331. Let us take a quick recap of an important observation that we can draw from the last 2 examples. You saw that we can keep a maximum of 9 balls in the first place. If we add one more ball, the group of 10 balls moves to the second place. In mathematical terms we say that the largest single digit number is 9. 9 plus 1 is 10. 10 is a 2-digit number, which also happens to be the place value of the second place. Again, suppose we have 9 balls in the first place. And 9 groups of balls, each group containing 10 balls, in the second place. If we add one more ball in the first place, we get a group of 10 balls. This group moves to the second place, making 10 groups in the second place. As we know, each group contains 10 balls. So, we have a collection of 100 balls in the second place. This collection of 100 balls moves to the third place, where it belongs. Mathematically, 99 is the largest two-digit number. Because, in both the first place and the second place we have the largest single digit, 9. 99 plus 1 is 100. As you can see, 100 is a three-digit number, which also happens to be the place value of the third place. In the same manner, 999 is the largest three-digit number. 999 plus 1 is 1000, which is a four-digit number. And 1000 also happens to be the place value of the fourth place. If we keep moving up like this, we can determine all the subsequent place values. Our next set of observations are even more important. These observations will help us understand why we call the decimal number system a base 10 system. This time we are going to make use of our currency note examples, instead of 10 as ball ones. When we have 10 1 rupee coins in the first place, these coins change into a 10 rupee note and move to the second place. Mathematically, 10 times 1 is 10. If you observe carefully, this means, on multiplying the place value of the first place by 10, we get the place value of the second place. Similarly, when you have 10 10 rupee notes in the second place, these notes change into a 100 rupee note. The 100 rupee note belongs to the third place. So we move it to that position. Mathematically, 10 times 10 is 100. This means, on multiplying the place value of the second position by 10, we get the place value of the third position. Continuing in the same manner, if the count of 100 rupee notes in the third position becomes 10. The 10 100 rupee notes change to their equivalent 1000 rupee note, and move to the fourth position. In mathematical terminology, 10 times 100 is 1000. That means, if we multiply the place value of the third position by 10, we get the place value of the fourth position. This 10 times rule is true for all the positions. In other words, in the decimal number system any place value, when multiplied by 10, gives the place value of the next higher position. This, exactly, is the reason why we say that the decimal number system is a base 10 system. And the name of the system itself is a reflection of this fact. The word decimal comes from a Latin origin word, which means 10. Finally, I would like to tell you that the decimal number system is also called the Hindu-Arabic system. To know more, you can watch our tutorial number 3.a and tutorial number 3.b. I will be back with a new tutorial very soon. Bye for now.